Hello, my name is Maverick Collins. This is my video submission for the compare sorting assignment for CST-201, algorithms and data structures, being taught by Professor Woodward. And in this assignment, we are tasked with building the sorts that we've been going over the past few weeks and putting them into practice, and then comparing them to one another to see how they stack up in terms of their efficiency. So let's go ahead and run the program. Enter the size of the array. So I've been doing, I think 10,000. It should give us a good data set here. Might take a little while. Bear with me. It's almost done here. Come on. Okay. So the size of the array, we did 10,000. And so the selection sort is, as you can see here, is very inefficient when it comes to larger data sets. Smaller data sets, it's probably quicker than some of the bottom three here. But when it comes to larger and larger data sets, it gets more and more and more inefficient. As you can see, did 50 million comparisons and really small number of exchanges. The reason is because the selection sort, how it works, it'll go through, compare, 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 and then once it finishes its pass through, then it exchanges or swaps them all at one iteration. So that's why it's so low in comparison to all the other ones. Similar with the bubble sort, however, as it goes, it does swap. So it's similar to the selection sort, except that it swaps them whenever it does a compare. Well, whenever it does a compare, after it does its comparison, it'll swap them. And then with the merge sort, of course, that's where it divides the array into two, into two, into two until it has finished doing its comparisons. And that's why you could see that they're pretty one-to-one here. And similar with the quick sort, however, it does a pivot. And so it'll select a pivot, do its comparisons, exchanges, do another pivot, comparison exchanges, etc. And an intersort is it's a hybrid sort with the, what is it? The heap sort and just had it up here. The heap sort and the quick sort. That's right. Heap sort and the quick sort. So again, the quick sort has the pivots where it's, making a pivot for each array, doing its comparison and exchanging them. And the heap sort's using like a binary heap almost. Well, yeah, and it's comparing those two. I had to reference a lot of resources to get that one to work. That was a tricky one. So yeah, definitely, I would say quick sort is probably the most efficient, it looks like, along with intersort, but that's a hybrid sort. I would say quick sort is the pure algorithms itself seems to be the better option of what we've been given here. So for the main runner, had this working as each of these as their own objects. Then through my research, I was able to refactor it to put them into just one single array and then go through and iterate each object. So each of these sorting algorithms is its own object or class. And then we instantiated them here into this array where we're shuffling, well, first creating the array and shuffling them. And then for each pass through, we're going to, where is it? Sorry, I got my zoom toolbar right here. I had another method. Yeah, right here, where it actually shuffles the array each iteration it goes through. And then we print the stats here where it's aggregating all the comparisons and the exchanges, storing them, and then outputting the final result. As you can see, that's the plus equals there. So here's my bubble sort. Again, I heavily reference Geek for Geeks and a few other resources, Stack Overflow, just to name a few. These were pretty, not that one. Bubble sort and selection sort were pretty, seamless, painless, quick sort, started to get a little more complex and or sorry, yeah, the merge sort again, pretty little more complex, but as a little more not as quite as involved as the quick sort and the intersort, the hybrid sort. This one was pretty gnarly. So anyhow, that's my submission for the compare sorting algorithms. I hope you enjoyed this one and learned a lot. Really challenging assignment. And yeah, we'll see you in the next one. Thanks.